Welcome back, guys. This is question 5.31 and the statement of this question is a random committee of size 3 is selected from 4 doctors and 2 nurses. Okay, so 2 nurses and 4 doctors write a formula for the probability distribution of the random variable x representing the number of doctors on the committee, and in the second part find p of x is greater or equal to 2 and less than or equal to 3. Okay, so in the given data, what are we given here? Okay, so the random number of items here are, let me call them 3, and we have doctors d equal to 4, total doctors and nurses NUR, these are equal to 2. Okay, these constitutes a total number of items, which is what? Which is 4 plus 2. So this constitutes the total number of items, which is 4 plus 2 equal to 6, and this is what? This is n. So we have all of these items. This d is equal to 4. So from it, first part is write a formula for the probability distribution of the random variable x representing the number of doctors on the committee. So let me solve it first. Solving it, and here we have to find the formula for the number of doctors. So here the total number of doctors here we have are 4, and if I want to select the k number of doctors from it, it will be 4, choose k. Similarly, the number of nurses here are 2. Okay, so the remaining number of items here will be the total number of items what I want to choose, and subtracting from it the number of doctors chosen. Okay, so the total number of items I want to choose are 3, and from it I have to subtract the number of doctors, so it would be this one. Okay, and I have to divide it over the total number of items. So the total number of items here are n, choose small n, and choose small n. Okay, or writing their values, let me write their values. So it would be 6, choose 3. Okay, so this is for what? This is for k, and it is the probability that x, which is basically what? Which is basically the number of doctors, it is equal to k. Okay, so this is what? This is the solution for part A of this question. Similarly, in part B, I have to find the probability that x is greater or equal to 2 and less than or equal to 3. Similarly, I have to find out the value of x is greater or equal to 2, less than or equal to 3, as the both of these items are here and available in it because of this equality sign. So it can be x is equal to 2 plus probability that x is equal to 3. Let me write these values. For them, I have to use the formula which is here. Okay, this formula. So here writing the values, so it would be for the first one, it would be for 4, choose 2, and here 2, choose 3 minus 2, so it would be 3 minus 2, so it would be 2, choose 1 divided by the 6, choose 3. Okay, similarly for x equal to 3, I will have 4, choose 3, and here it would be what? It would be 2, choose 0 whole divided by 6, choose 3. Okay, so let me move down somehow, taking the LCM here. So in this LCM we will have this overall, so it would be 6, choose 3, and here we will have 4, choose 2, 2, choose 1, plus 4, 3, 2, 0. Okay, solving it, I will get here, let me move down somehow more, it will become 4 factorial divided by 2 factorial into 2 factorial multiplied by 2 factorial divided by 1 factorial and 2 minus 1 is again 1 factorial plus 4 factorial divided by 3 factorial and 1 factorial multiplied by 2 factorial divided by 0 factorial and 2 factorial because 2 minus 0 is 2. Similarly, whole divided by 6 factorial divided by 3 factorial and 6 minus 3 is again 3 factorial. Okay, so let me solve it, and solving it, it will be 4 multiplied by 3 is 12. 12 divided by 4, so it would be 3 multiplied by 2. Okay, plus it is what? It will be 4 multiplied by 1, so it will be 4 divided by, here it will become what? It will be 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial whole divided by 3 into 2 multiplied by 3 factorial. These two will cancel out. It is 2 to 4. It is 3 to 6. So it will be 20. Okay. So it will become 3 to 6, 6 to 12. 12 plus 4 is 16 divided by 20. Okay. So it would become 4 by 5, which is what? Which is basically the solution of our question. So let me move offside. Okay, so the answer of it is 4 divided by 5, and this is what? This is the solution of this one. So that's it for today, in which we have seen the solution of question 5.31. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.32, and the statement of this question is, from a lot of 10 missiles, 4 are selected at random and fired. If the lot contains 3 defective missiles that will not fire, what is the probability that A, all 4 will fire, and B, at most 2 will not fire? Okay, 4 fire will means all 4 are not defective. Okay, so this is what we have. Now let me first write the given data here, and in given data we can very clearly see here that the total number of missiles here are 10, and the selected number of missiles which are selected at random from these 10 missiles are small n, and that is equal to 4. Okay, from here it is already known that the defective number of the missiles are 3, and non-defective or ND are, these are 10 minus 3, these are 7. Okay, so in solving it, in part A all 4 will fire. What does it mean? Let me solve them here, and in part A we have to write that all 4 will be selected from these things. Okay, so all 4 will be from it, and there will be none of them. So therefore it is what? It will be 7 choose 4, because all 4 will be from this 7, and from this 3 there will be none, and also the total number of items where will be, and choose small n, so it would be 10 choose 4. Okay, so this is what? This is the equation for the hypergeometric probability distribution, and for it I can see that here I have to select these 4 items, and these are from total number of n, the selected number of items 4, and the k value here is 7. Okay, so this is what we have. Let me solve it. So it would become 7 factorial divided by 4 factorial into 3 factorial. 3 choose 0 is already known, and that is 1, and also this one 10 factorial divided by 4 factorial into 6 factorial. Okay, so let me solve it. So 7 factorial is 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial whole divided by this 4 factorial, okay, multiplied by 3 factorial is 6. Okay, this will cancel out with this one, this with this one, so it would be 35, and this one here when you calculate it, it would be 210. So it would be 35 divided by 210, and solving it, it will give me 1 by 6. So answer of it is 1 by 6. Okay, so the probability of for part A of my question is 1 by 6. Similarly, in part B, let me solve it here. In part B, I have to solve that at most 2 will not fire. So I have to find the probability that the not firing items here are, or the non firing missiles here are less than or equal to 2. Okay, so I have to find them out, and here it is what, this is less than or equal to this one, and let me solve for it. It would become what, let me give it a value k equal to 0 up to 2. All of these values are included. So let me write here all the not firing missiles. So these are 3 or D. Okay, so these are 3, and from it I have to sample the k number of items. Okay, the remaining ones here are which are working are 7, and here we will have the remaining items. So the selected items are 4, and if k are selected here, the remaining items will be here, and also divided by 10 choose 4, which is already known, and that is calculated is 210. Okay, so it will become what, let me calculate them for all the values. So all the values here, let me move down somehow. For all the values here, it would become 3 choose 0, and here it would be 7 choose 4 for the value of 0, 210, plus for k equal to 1, 3 choose 1, 7 choose 3 whole divided by 210, plus 3 choose 2, and 7 choose 4 minus 2 is 2 divided by 210. Okay, so once it will be calculated and all the values will be found out, it would be 29 by 30, which is what, which is the solution of part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.32. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.33, and the statement of this question is, if 7 cards are dealt from an ordinary deck of 7 to 2 playing cards, what is the probability that A, exactly 2 of them will be face cards, B, at least one of them will be a queen? Okay, so the given data here, okay, again here the total number of cards are 52. Okay, from which we will have to sample 7 cards. Okay, in part A of it, we have to see that exactly 2 of them will be face cards. Okay, so in part A, let me use this black color for it. In part A, I have to see that exactly 2 are face cards. Okay, so how many face cards are in cards? So there are basically 4 jack cards, 4 queen cards, and 4 king cards. So in total there would be 12, which are basically face cards, or these are also court cards or face cards. Okay, so there are 12 cards, and from those 12 we should have 2. Okay, and also the remaining cards are 40, because 40 plus 12 are 2, and from these 40 the remaining cards would be 7 minus 2, which are 5. Okay, so these are what we have. So let me arrange them as well. From the 12 face cards, I have to choose 2 cards, and from the remaining 40 cards I should have 5. Okay, so here again this is the problem of the hypergeometric probability, where what we will have, the face cards are 12, and from those 12 I have to select 2. Okay, the remaining cards are 40, and from them I have to select 5. Okay, while dividing it over the total number of cards, which are 52, choose 7. Okay, so this is what this is: h of 2, 52, choose 7, and then 12. Okay, so this is what we have here, and when we will solve it, the answer of it will be what? The answer of it will be 0.3246, and that is what, that is basically the solution of part A of my question. The only thing here is the understanding of it. Okay, and from it we have to understand this one, and then it will be easy for us to solve it. Now part B of my question, let me move down somehow. In part B of my question, I have to see that at least one of them will be a queen. So I have to see the probability that if x are basically the number of queens, so at least one of them will be queen. It will be greater or equal to 1, which can also be written as 1 minus probability that queen is 0. Okay, no queen will be here, so therefore it can be written as what? How many queens do we have here? We have 4 queens, and we, if x is equal to 0 or no queens, so from 4 we should have no queen. Okay, the remaining cards here are 52 minus 4, so those would be 48, and from 48 I have to select all the cards, which are 7. Okay, and dividing it over the total number of cards, which are 52, choose 7. Okay, so it would become what? It would become 1 minus 4, choose 0 is 1, so it would become 48, choose 7 whole divided by 52, choose 7. Okay, so the answer of it would be 0.4496, and that is what, that is basically the solution of part B of my question. Okay, so we have seen the solution of question 5.33, in which the solution is related to the hypergeometric probability theory. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is chapter 5, and today we are going to solve question 5.34 and 5.35. Both of these questions are closely relevant and related to the hypergeometric probability distribution. So let us first start with question 5.34. So the statement of this question is, what is the probability that a waitress will refuse to serve alcoholic beverages to only 2 minors if she randomly checks the IDs of 5 among 9 students, 4 of whom are minors? Okay, so let us first indicate here that what is the given data. Here she has to select 5 students out of 9, so here this is capital N, out of which she has to select 9. Okay, and also the minor students here are 4. Okay, so if 2 of the 5 are basically the minors, she will reject alcoholic beverages. Okay, so in solving it, let me solve it first. So this is 5.34, and in solving it, we have to do what here? First of all, we have to write the 4 minor students, and out of those 4 she has to select 2. If 2 of them are basically the minors, okay, what will she do? She will reject the alcoholic beverages. Similarly, the remaining students from 9 are basically the adults. Okay, and she will select 5 of them, so 3 will be from the adults, and similarly the total selections here would be 5 out of these 9s. Okay, so it is what? It is basically the hypergeometric probability distribution, and here I have to select 2 from 9 5, okay, and here 4 as well. Okay, so let me solve it. When I will solve it, the answer of it will be given, and the answer of it will be what? 60 divided by 126, or 10 divided by 21, which is equal to 0.47, and that is what? That is basically the solution of question 5.34. Similarly, in solving question 5.35, the statement of it is a company is interested in evaluating its current inspection procedure for shipment of 50 identical items. Okay, so the identical items are 50. The procedure is to take a sample of 5 and pass the shipment if no more than 2 are found to be defective. What proportion of shipment with 20% defective will be accepted? Okay, so if the 20% items are defective here, so the total number of items here are 50. Okay, and a person has to select what? 5 items from it. So with 20% defective items, 50 multiplied by 20% is 20 divided by 100. So it is what? This will cancel out, and those would be the 10 items. So the 10 defective items will be selected. Okay, there will be 10 defective items from it. So n is 50. There will be 40 undefective items and 10 defective items. Okay, from it a person will select 5 items, and if more than 2 are defective items, okay, so what will happen? The shipment will be rejected. Okay, so the defective items must be less than this 2. So let me solve it now, and I think the problem is now clear to you guys because of this diagram here. So in order to solve it, let me here choose this color, and here in order to accept it, the probability of acceptance is what? We will have all the items x from 0 to 2, and all of these items will be what? Will be from the defective items, which are 10. Okay, and the remaining items here are 40, and all the other items were from it, so it would be 5 minus x. Okay, and whole divided by what? Whole divided this 55. Okay, so what will happen here? Let me write it here. So it will become 10, choose 0, 40, choose 5, whole divided by 50, choose 5. Okay, similarly plus this one now 1, 10, choose 1, 40, choose 4, whole divided by 50, choose 5. Okay, also here let me expand it, because here we have from 0 to 2. Also here 10, choose 2, 40, choose 3, whole divided by 50, choose 5. Okay, so now when I will solve it, the answer of it will become 0.95 is the answer of our question. After solving it, we will see that this is the solution of our question. Okay, so that's it for today, in which we have seen the solution of 2 questions which are related to the hypergeometric probability distribution. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.36, and the statement of it is a manufacturing company uses an acceptance scheme on items from a production line before they are shipped. The plan is a 2-stage one. Boxes of 25 items are ready for shipment, and a sample of 3 items is tested for defectives. If any defectives are found, the entire box is sent back for 100% screening. If no defective are found, the box is shipped. Okay, so on the basis of it, let me first write that what is given here. So the total number of items here are 25, and from these 25, a person has to select 3 items. Okay, so according to this statement, if any of these 3 is found defective, what will happen? Entire box is sent back for 100% screening, so send back. Okay, also if none is defective, it will be shipped. So what is this? This is the entire statement. So on the basis of it, part A of our question is, what is the probability that a box containing 3 defectives will be shipped? And in B, what is the probability that a box containing only 1 defective will be sent back for screening? Okay, so I think these statements are now clear. Let me solve it. And in solving part A of our question, we can see that here, if we have the defective items in the lot are 3, okay, what is the probability that it will be accepted for shipment? Okay, so what will happen here? I have to use what? I have to use the hypergeometric probability distribution, because now I have the number of items here. So first of all, let me write the total number of combinations. So from 25, 3 items should be taken. 25, choose 3. These are the total number of items or the combinations which has to be taken from these 25 items. Similarly, if 3 defective items are present in it and it is accepted for shipment, it means that none of these 3 items is selected here. So means 3 are available in the 25 while none is selected within the scrutiny time. Okay, similarly, the remaining items were 22 which were non-defective, and all the 3 items were selected from these 22. Okay, so this is basically the formulation of the problem for part A, and this is H 0 from 25 3 and K is also 3. So from it I have to select all this. So let me solve it, and this would become what? It would become 1. This is 1. So let me write the other important stuff. So it would be 22 factorial divided by the 3 factorial, and 22 minus 3 is 19 factorial, whole divided by 25 factorial, whole divided by 3 factorial, and 25 minus 3 is 22 factorial. Okay, so when solving it, the answer of it will become 77 divided by 115. You can solve it and you can see that the answer will be here. So this is the solution for part A of our question. Okay, so I think you have understood all the things which we have done here. In part B of our question, what is written? What is the probability that a box containing only 1 defective will be sent back for screening? A box now contains only 1 defective item, and in scrutiny time that defective item will be selected and the entire box will be sent back. So this is part B. And here now the defective item is only 1. Okay, so again using the hypergeometric probability distribution, so here the total items are again 25, choose 3. Okay, now the defective items are 1, and during the scrutiny only that defective item is selected. The remaining items here are 24 which are non-defective, and 2 out of them are selected. Okay, so this is what, let me write the hypergeometric formulation for it. It is 1 from 25 3 and K is also 1. Okay, so this is what we have here. Again this one will be 1 as well, and solving it again it would become 24 factorial divided by 2 factorial multiplied by 22 factorial. Okay, because 24 minus 2 is 22, and also here it will be the same one as it is, so it would be 25 factorial whole divided by 3 factorial multiplied by 22 factorial. Okay, so solving it at the end, what we will get, it would be 3 by 25, and that is basically the solution of part B of our question. Okay, so that's it for today, in which we have seen the solution of question 5.36. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.37, and the statement of it is, suppose that the manufacturing company of exercise 5.36 decides to change its acceptance scheme. Under the new scheme, an inspector takes one item at random, inspects it, and then replaces it in the box. A second inspector does likewise. Finally, a third inspector goes through the same procedure. The box is not shipped if any of 3 inspectors find a defective item. Answer the questions in exercise 5.36 for this new plan. Okay, so let me first paste it here, exercise 5.36, and we have to see that what has been asked in that question. So let us paste 5.36. So this was exercise 5.36, in which we had the total number of items equal to 25, and out of them 3 were selected. But now, as the strategy has been changed, but we have to answer these part A and part B. Okay, so first of all, let us see that what is the strategy here which has been passed. So let us have 3 inspectors here. Okay, these are the 3 inspectors, 1, 2, 3. To each one of them, a carton containing 25 items. The first inspector will receive a bag containing 25 items. He will select only one of these 25 items, will check it and forward it to the second inspector if it is non-defective. Otherwise, what he will do, he will send it back. Similarly, what he will do during the forwarding time, he will place back the item which he picked, and then he will forward it to the second inspector. The second inspector now will receive 25 item. What he will do, he will again a single item randomly from these 25 items, will check it, and if that is undefective, he will place it back in the bag and forward it to the third inspector. If that item which he picked is defective, what he will do, he will send it back and will not forward it. Okay, the third one will again get the 25 items. He will again pick a single item randomly from it and follow the same procedure. What he will do, he will check it. If that item is undefective, he will ship it. Otherwise, he will send it back and will not recommend it for shipping. So that is the overall procedure which will be followed here. So in order to solve it, let us have part A. What is the probability that a box containing 3 defective items will be shipped? Okay, so a box containing 3 defective items would be if the total number of items are 25 and 3 are defective. So the undefective items are 22. Okay, to each one of them, the probability of selecting the undefective item would be 22 divided by 25, due to the probability theorem that the probability here will be the number of items divided by the total number of items. So here he will get it. So the probability of getting it here would be 22 by 25. This is what? This is the probability of acceptance. Similarly, when the item will be put back, the same probability will be followed here. Okay, and the same will be followed here as well, because this is the sampling with the replacement in each of the step. Okay, so I hope you have got it. Now, in order to combine them all, we can see that this each one of them here has been doing the sampling with replacement and independently. Okay, so here I have to multiply them together. So multiplying them together, what I will get? We will get 22 by 25 whole cube, and from it what will we get here? Calculating it, we would get 10,648 divided by 15,625. So the answer of it would be 0.6838. Okay, so that is what, that is the solution of part A of my question, which is the probability that a box containing 3 defective will be shipped. In part B of my question, what is the probability that a box containing only 1 defective will be sent back for screening? Okay, so let me move down somehow. Again, following the same procedure here, if it will contain only 1 defective item, so the undefective item would be 24. So the probability of passing through here would become what? For part B, it will become 24 by 25. From here, it would again be 24 by 25 because the sole principle remain the same. And here it will again be 24 by 25 because this is the probability of passing through all of them. Okay. So what we will get from here, it would become 24 by 25 whole cube. Okay, so this is the probability that if a box contain only 1 defective item, it will be shipped, okay, or pass through all of these 3 inspectors. But the question here is that if what is the probability that a box containing only 1 defective item will be sent back for screening and will not be shipped? So it will be what? Which is the opposite of it, and it would be 1 minus 24 divided by 25 whole cube. Okay, finding it out, what will we get? It will be 1801 divided by 15,625, and the answer of it would be 0.1153, and that is what, that is the solution of part B of my question. Okay, so I hope you have understood all the solution and what do we have to do, and that is what, that is basically the solution here we have. So that's it for today. If you have any question, you can put it in the comment box and I will answer those questions. See you soon. Welcome guys, this is question 5.38, and the statement it has is, among 150 IRS employees in a large city, only 30 are women. Okay, 150 are the total employees and 30 of them are women. If 10 of the employees are chosen at random to provide free tax assistance for the residents of the city, use the binomial approximation. Okay, we have to keep it in our mind, to the hypergeometric distribution to find the probability that at least 3 women are selected. Okay, so let me first write the given data. Okay, in a city we have a total employees 150, out of them 30 are women. Okay, and now out of these 150, 10 are randomly selected. Okay, so this is what, this is clearly the case of the hypergeometric distribution where 3 women has to be selected. So now in order to find out here the probability that x is greater or equal to 3, if x is a random variable which is basically the number of women out of these 10, it can also be written as 1 minus the probability that x is less than 3. Okay, then in order to find out this probability, what we can do, we can write here x is less than 3. For it, all the less than 3 values would be the probability that x is equal to 0 plus the probability that x is equal to 1 plus probability that x is equal to 2. Okay, these are all the values. Then it can be written as, if I write this as x equal to 0 up to 2, okay, this is the small x, it can be written as probability that x is equal to small x. Okay, this is what we have. Now let me proceed it by going somehow downwards. Okay, so it is what I can very easily write here, the hypergeometric probability distribution. From it, the total number of items are 150. Out of them 10 are selected. Okay, then if I want to find out the number of women out of these 10, the number of women from in the total number of items are 30. From it, if I have to select the items which are x, it would be here. Add the remaining items which are the men are 120, and the remaining item would here become 10, which are the total number of selected item minus the number of women which are selected, and it would be for what? It would be for all the values from 0 to 2, and this is what? This would be the probability that x is less than 3. Then taking this value, putting it here, we can find our solution. Okay, this is by using the hypergeometric probability distribution. But the question and the scenario here is that this would be a very huge number, because here you can see that this is a number very huge, this one will be very huge, this one also be very huge, so it wouldn't be computationally very feasible to find it out. So despite it, what we can do here is that, as given in this question, we can use binomial distribution approximation. Okay, so in order to do the binomial distribution approximation, what we have to do, out of this we have to find the probability of x, which is the p, the probability of women in the number of employees. So it would be 30 divided by 150, so it would be 0.2. Now this is the probability of the women out of this 150, which is the population size. Now out of this population, we have selected this sample, and out of these samples I have to find out the probability that women selected are at least 3. So again here we have, this is the probability which is given, the number of items here now we have 10, while the values of k would be 0, 1 and 2. Okay, we have to find them out and then subtract them from 1. So it would be the probability that x is greater or equal to 3. It would be 1 minus the probability that x is greater than 2. Using the binomial probability, what we can write here, it would be the binomial. Okay, where the values of k will be here, and also the number of samples are 10 and the probability is 0.2. Okay, so let me solve it for this case, and it is probability that x is greater or equal to 3. So let me solve it by going downwards. Okay, so here we have, so this is what? This is the probability that x is greater or equal to 3. So it would be 1 minus this binomial. So writing it here, it would be for x is equal to 0 up to 2, and it is what? It is 10, choose x. Okay, and then the probability which is 0.2, taking it, writing here x, and 1 minus 0.2, 10 minus x. Okay, so let me write these values. It would be for all the values of x, it would be 10, choose 0. For the first one here, it would be 0.2, 0, and 0.8, 10. Okay, plus, let me use it like this. Similarly, 10, choose 1, 0.2, 1, and 0.8, 9, because this is 10 minus 1 is 9. Okay, Similarly, the last one, 10 choose to 0.2 raised to power 2 and 0.8, 10 minus 2 is 8. So this is what we will find. So after finding it out, subtracting it from 8, what we will get, it would be 0.323. Okay, so that is basically the solution of our question. From this question and from this, you can also find out the similar solution, but it wouldn't be that much computationally easier as we have done it here. Okay, so that's it for today, in which we have seen the binomial approximation for the hypergeometric probability problem. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is chapter 5, and today we are going to solve question 5.39, 5.40 and 5.41 due to the very high relevancy of these three questions. So let me first go through the statement of the question 5.39. An annexation suits against a county subdivision of 1200 residents is being considered by a neighboring city. If the occupants of half of the residence object to being annexed, what is the probability that in a random sample of 10 at least 5 favor for the annexation suit? Okay, so the annexation probability here is this. Okay, let me first write here the solution for this question, and here writing the probability of annexation here, this is what, this is half of the residence, so it would be 0.5. okay, we know that, and the total number of residences are here 1200. So now we know what, we know that 10 are sampled, and out of those 10, at least 3 favor the annexation. Okay, so here the number of samples are 10, and I want to find out the probability that X, which are the people in favor of the annexation, are greater or equal to 3. This would be 1 minus the probability of X less than 3. Okay, so this is what, this is clearly the binomial probability theorem, in which we have all of this, and here we will do what, we will basically use the binomial approximation. Okay, we want to do it. So in order to do the binomial approximation, here it would be what, it would be 1 minus, this is the probability that X is less than 3, so it would be, let me write here this K, it is from 0 to 2, all the values are less than 3, and using the binomial theorem here, which is the N choose K, so here N is 10, so choose K is here. Okay, the probability of annexation is P, which is 0.5 and raised to power K, and 1 minus 0.5, 10 minus K. Okay, so let me use this one as well, and here it would become what, it would be 10 choose 0, 0.5 raised to power 0 is 1, and it would be 0.5 this power, sorry, this is K. Okay, so it would become 10 minus K, so it would be 10. Similarly, for the value of K equal to 1, it would be 10, choose 1, 0.5 raised to power 1, and here 0.5, 1 minus 0.5 is 0.5, this is 9. Okay, and the last one here would be 10, choose 2, 0.5 raised to power 2, and 0.5 raised to power 8. Okay, so that is what we have. After finding it out, all of them, and then subtracting it from 1, what would I get here? It would be the probability that X is greater or equal to 3. It would be 0.945, and this is what, this is basically the solution of question 5.39, and you have seen that this is basically the usage of binomial approximation, which has been by this formula. Okay, so that is for question 5.39. So let me remove it, and now let me move to question 5.40. It is estimated that 4,000 of the 10,000 voting residents of a town are against a new sales tax. Okay, so here the total number of voters and the number of voters which are against the tax are given here. So from it we can write the probability. So it would be 4,000 divided by 10,000. Okay, so it would be word 4 by 10, so it would be 0.4. So this is basically the probability that the random person is against the sales tax policy, and the probability that a person is proponent of the tax policy, that would be 1 minus b, and this is 0.6. From it we have deduced it. If 15 eligible voters are selected at random and asked their opinion, what is the probability that at most 7 favor the new tax policy? So again here n is what, and is 15, and here we have to find that what is the probability that at most 7 favor the tax policy, means the 7 are proponent of the tax policy. So at most 7 means I want to find out the probability that if x is the number of people which are in favor of the new tax policy, so we have to find this one. Okay, so this is what we want to find out. So in order to find it out, what we can do, again we have here the probability of the favor, and we have the total number of people here as well. So what we can do in order to find it out, this one can be very easily found out by k equal to 0 up to 7, because this is up to 7, and here writing the n which is 15, choose k. Okay, so now as we want to find out the people who are in favor of the tax, so this is the probability we have. So this is 0.6 raised to the power k, and 0.4 which is 1 minus 0.6, that is 15 minus k. Okay, so that is what we want to find out. So then we have to do what? We have to calculate it out, and after calculating it, the answer of it would be 0.2131, and that is what? That is the probability that x is less than or equal to 7, and that is what we wanted to find out here. Okay, so that is what, that is basically the solution of question 5.40. So this is what we have done. So in question 5.41, a nationwide survey of 17,000 college seniors by the University of Michigan revealed that almost 70% disapprove of daily pot smoking. Okay, so here the probability of the disapproval of daily pot smoking is 0.7, which is visible from this 70% figure. If 18 of these seniors are selected at random, means the total number of items are 18. Okay, and ask their opinion, what is the probability that more than 9? Okay, so we want to find out the probability that the x, which is the number of college seniors, is greater than 9, which is greater or equal to 10, and fewer than 14 disapprove of smoking the pot, means less than or equal to 13. Okay, we want to find it out. Okay, so this is the similar type of problem, and here in order to find it out, we can write what? We can start k from 10 up to 13. Okay, the number of items here are 18, choose k. Okay, and the probability is already given. This is 0.7 raised to the power k, and also 1 minus 0.7, that is 0.3, and 18 minus k. Okay, so what we have to do after it, we have to expand it. So let me expand it. expanding it, we will get 18, choose 10, okay, 0.7 raised to power 10 multiplied by 0.3 multiplied by 18 minus 10 is 8, okay, plus the second one is after 10 we have to have 11, so 18 choose 11 and 0.7 raised to power 11 and 0.3 raised to power 11 minus 18 minus 11 is 7 plus after 8 18 choose 12 0.7 raised to power 12 and 0.3 raised to power 18 minus 12 is 6, okay, and the last one here would be, let me move down somehow or here, okay, so the last one here would be 18 choose 13 and probability is 0.7 choose 13 and 0.3, 18 minus 13 is 5, okay, so we have to do what, we have to add them all, okay, we have to add all of them, okay, adding them, what will be the answer, 0.6077, and this is what, this is basically the probability that x is greater or equal to 10 and less than or equal to 13, and that is what, that is basically the solution we wanted to find out, okay, so that's what we wanted to find out, and that is basically the solution of question 5.39, 40 and 41. And in all of these questions we have seen what, we have seen the application of the binomial approximation. So that's it for today. If you guys have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 5.42 and the statement of this question is, find the probability of being dealt a bridge hand of 13 cards containing 5 spades, 2 hearts, 3 diamonds and 3 clubs, okay. So this is what, this is the given statement of my question, and here the given is, if a person chooses 13 cards, what is the probability that out of those 13 cards he will have 5 spades, 2 hearts, 3 diamonds and 3 clubs. So you can count them and it would be 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 5 is 13, okay. So we have to find the probability of this combination, okay, and in total cards, the total number of spades are 13, the total number of hearts are 13 as well, 13 diamonds and 13 clubs as well, okay, adding them all together it is 52. So from the 52 we have to select 13 cards, and what is the probability that out of those 13 cards we will have 5 of this, 2 of heart, 3 of D and 3 of C, okay. So this is clearly the hypergeometric probability problem, and here first of all, what do we have to do in all of these problems? What do we have to write? In the denominator, we have to write the total number of cards, from it the chosen number of cards. So total number of cards here are 52, from which I have to choose 13. Okay, and the first combination is the spades and the total number of 13 spades. Similarly, second one are hearts, 13 are hearts. Third one are the diamonds, 13 diamonds, and the last one are this club, so 13 clubs as well. So out of them I have to select what, let me use this color. From 13 I have to choose 5. Out of these 13 hearts we have to select 2. Then 13 diamonds, we have to select 3, and from 13 clubs we have to select 3 as well. Okay, so solving it, let me move down somehow. Solving it, we will get 13 factorial divided by 5 factorial. 13 minus 5 is 8 factorial multiplied by the 13 factorial divided by 2 factorial, and 13 minus 2 is 11 factorial multiplied by 13 factorial divided by 3 factorial. 13 minus 3 is 10 factorial multiplied by 13 factorial divided by 3 factorial multiplied by 13 minus 3 is 10 factorial as well, divided by the overall combinations here, which would be 52 factorial whole divided by 13 factorial, and 52 minus 13 is 39 factorial. Okay. So solving it and then finding the answer of it, what we will get 0.0129, and that is what? That is basically the solution of our question, what we were solving in this video. So that's it for today, in which we have seen the solution of question 5.42, in which we had to select the categories of the items from the total of 4 categories, and that is what we wanted to solve in this question. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.43, and the statement of this question is: a foreign student club list as its 2 Canadian, okay, 3 Japanese and 5 Italians and 2 Germans. If a committee of 4 is selected at random, find the probability that A, all the nationalities are represented, B, all nationalities except Italian are represented. Okay, so first of all, let me write here the given data. What is given here? So the nationalities we have here are Canadian, okay, Japanese, okay, Italian, and the last one is German. Okay, so the number of Canadians are 2, the number of Japanese are 3, the number of Italians are 5, and the number of Germans are 2. So the total number of the members are 2 plus 3 plus 5 plus 2. So this is equal to 12. Okay, so the 12 number of total members. So from it, what do we have to do? We will select the out of them and it, we have to select at random 4 members. Okay, 4 members have to be selected, and on the basis of it we have to solve part A and part B. So in part A, this is, let me call this solution. In part A, we have to see that all nationalities are represented, means in these 4 members, all the members are from Canadian, Japanese, Italian and German. So therefore each one will be represented, and a person from each of these nationalities will be selected, which are 1 1 1. Okay, so therefore it is the similar hypergeometric probability problem, and here we have to divide it over the total number of elements, which are what? Which are from the 12 we have to select 4, which are the total number of the selections, and then we will have what? We will have the Canadians, okay, we will have the Japanese. Canadians are 2, Japanese are 3, Italians are 5, and Germans are 2. Okay, from each of them we must have 1 1 1 1. So 1 plus 1 plus 1 plus 1, these are 4 which are here as well. Okay, so let me solve them here. So solving it, it will become 2 factorial divided by 1 factorial, so it will be 2. Okay, it will be 2 multiplied by this 3 multiplied by 5 multiplied by 2. You can solve it and you will see that it will be 2, because 2 factorial divided by 1 factorial divided by 2 minus 1 factorial is 2. Okay, so and so on. You can solve them and you will see that these will be this one. And similarly here, it will be 12 factorial divided by the 4 factorial multiplied by 12 minus 4, 8 factorial. Okay, solving them, what we will get, the answer of it will be 4 divided by 33. So that is basically the solution of part A of my question. Okay, in part B, all nationalities except Italian are represented. Okay, so if none of the Italian will be selected, we can very clearly see here that the number of Italians here are 5. Okay, the 5 Italians we have, and from them we don't want to select anyone, so therefore it will be 5 factorial divided by 0 factorial, and 5 minus 0 is 5 factorial, so these will cancel out. 0 factorial is 1, so therefore the answer of it will be 1. Okay, solving the remaining part of it, what do we have to do? Here we have all of these items, and here this is the B, and in selecting the remaining items from Italian, I have to select the 0, and then from we will have Canadian, Japanese, and Germans. Okay, we have to select them in such a way that the total number of the members here are 4. Okay, so in how many ways can we do it? It can be 2, 1, 1, 2 Canadian, 1 Japanese, 1 German. Okay, this is the one combination. Similarly, we can have here 1, 2, 1. We can add them and we will see that this will be 4, and also we can add them like 1, 1, 2. Okay, so these are what? These are basically the 3 combinations: 2 Canadians, 1 Japanese, 1 German, or 1 Canadian, 2 Japanese, 1 German, or 1 Canadian, 1 Japanese, and 1 German. So these are basically the combinations which can be adopted if the Italians are not included. So therefore, adding them here, what we can get here again, using the hypergeometric probability distribution, the Canadian total number of Canadians are 2 for the first combination, the Japanese are 3, and also Italians are none, and Germans are 2. Okay, for the first combination we have 2, 1, 1, so therefore we will write 2, 1, 1 whole divided by the total number of combinations, which are the similar one as it is. Okay, so it will be 12 choose 4. Okay, or we can have this combination as well. Okay, we can have this one as well. So writing it here again, the total number of Canadians are 2, the total number of Japanese are 3, the total number of Germans are 2. Okay, from it now I have to select 1 from the Canadian, 2 from the Japanese, and 1 from the German. Okay, and whole divided by the 12 choose 4. Okay, this is what we have, and plus here. So let me move here as well. Okay, this one, and now we can see here that again we have this third combination 1, 1, 2. Here the total number of Canadians are 2, the total number of Japanese are 3, and the total number of Germans are 2 as well. Writing the combination 1, 1, 2, so 1 from the Canadian, 1 from the Japanese, and 2 from the German, whole divided by what? 12 choose 4. Okay, so we have to do what? Let me calculate it, and calculating it and then adding them all, we will have here this overall, this LCM, and then writing them all here 2, 2, 3, 1, 2, 1 plus 2, 1, 3, 2, 2, 1 plus 2, 1, 3, 1, and 2 2. Okay, solving it, let me move down somehow. So solving it and then writing the answer of it, it will be 8 divided by 165, and that is basically the solution of part B of my question. Okay, so that's it for today, in which we have seen the solution of question 5.43. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 5.44, and the statement of it is an urn contains 3 green balls, 2 blue balls and 4 red balls. Okay, so first of all, let me write the given data. In an urn we have green balls, blue balls and red balls. The number of green balls are 3, the number of blue balls are 2, and the number of red balls are 4 in a random sample of 5 balls. Okay, so let us have or choose this one. If a random selection from it has been taken and we have selected 5 balls randomly from them, okay, and the total number of balls here we have 3 plus 2 plus 4, these are 9. Okay, adding them and we will get 9, and this is what this is, and from it we have chosen 5 balls. Find the probability that both blue balls and at least 1 red balls are selected. Okay, so now solving it, this is the solution. We can very easily see that the total number of selected ball will be 5, and if all the 2 balls are selected, okay, 5 minus 2, so the remaining balls are 3 in number. Okay, so we know that all of these 2 balls are the blue one, and out of the 2 blue balls we have selected the 2 ones, so it will be 2 choose 2, so it would be 2 factorial divided by 2 factorial, 2 minus 2 factorial, this is 0 factorial, this is also 1, so it will be 1. Now in the remaining 3 balls, all items will be green and red, and the statement given here is that at least 1 red ball should be here. Okay, there shouldn't be any combination in which we don't have any red ball. So therefore, the number of combinations for this 3 we can have are, this is red, this is green. For the first combination, we can have 1 red ball and 2 green balls, and adding them we can have this 3. Okay, 1 plus 2. Similarly, we can have 2 red balls and 1 green ball. The conditions are satisfied, and we can see that adding them together we can get 3, and the last one here can be 3 and 0. Adding them together we can get 3, and also the red balls are available. We cannot here have 0 3, because writing 0 3 here we will violate this condition and it is not admissible. Okay, so we cannot use this condition, so therefore we are removing it. So therefore these are the conditions. So let me write these conditions here. These are the conditions, and for them we will have here either this situation, and for it we will have the red ones. So the total number of red balls are 4. Okay, and the other ball is green, so the total number of green balls are 3. Okay, from 4 we have to select 1 red ball, and from the 3 we have to select 2 green balls as it is given here, and dividing it over what? Dividing it over the total number of combinations, which are from the total of 9 balls we have to select 5 balls. Okay, we already know that the 2 balls are the blue one, which is the mandatory condition. So 9 choose 5. Okay, so this is what we have, and let me indicate that which combination is it. This one is this one. Okay, or we can have another condition, and that condition is here, this one. Okay, let me write it here, and here writing it we can see that the total number of red balls are 4 again, the total number of green balls are 3, and in this condition we have selected 2 red balls and 1 green ball, and this is what we have, and dividing it over the total number of the combinations, which are 9 choose 5. Okay, so this is what we have. Okay, now let me move it to the other side. Okay, this one, and the third combination here is, let me use this color, this one is here. Okay, let me write it here. So this condition can also occur, and this is again or, plus means or, and also here the total number of red balls are 4, the total number of green balls are 3. Okay, from 4 we have to select 3. Okay, and from the 3 green balls we have to select none of them, and dividing it over 9 choose 5. Okay, again writing them, we will get what this would be. 9 choose 5 is the LCM, and here we will have 4 choose 1, 3 choose 2, or 4 choose 2, 3 choose 1, or 4 choose 3, 3 choose 0. Okay, so these are what we have here. Now solving it, what we will get, the answer of it will be 17 divided by 63, and that is what we have got after solving this one. Okay, so that's it for today, in which we have seen the solution of question 5.44. If you guys have any question, you can ask me in the comment box. See you soon.